Hello my lovely students, you are welcome to a new lesson. Today I shall be teaching you number and numeration, and we shall be looking at logarithm of numbers less than 1. From definition, logarithm means power or index or exponent. The logarithm of a number in base 10, which is called the common logarithm, is the power to which 10 is raised to give that number. We have an example here. If 1000 is the same thing as 10 raised to power 3 in index form, then the logarithm to base 10 of 1000 is 3. Let's learn more about logarithms. Moving on, we have a table here for number, power of 10, and common logarithm. For 100,000, the power of 10 is 10 raised to power 5. Its common logarithm is 5. For 10,000, the power of 10 is 10 raised to power 4. Its common logarithm is 4. For 1000, the power of 10 is 10 raised to power 3. Its common logarithm is 3, and so on. Looking at for numbers less than 1, for 0.1, the power of 10 is 10 raised to power minus 1. This gives a common logarithm of bar 1. That is minus 1 in logarithm form. For 0.01, the power of 10 is 10 raised to power minus 2, which gives a common logarithm of bar 2. For 0.001, the power of 10 is 10 raised to power minus 3, which gives a common logarithm of bar 3, and so on. Please take note of this table. For number, power of 10, and common logarithm. Moving on, let's see the parts of a logarithm. A logarithm has two parts. The first part is the characteristic or the integer, which can be found in standard form, while the second part of a logarithm is the mantissa or the decimal fraction, which can be found in your 4-figure or mathematical tables. Looking at logarithm of numbers greater than or less than 1. To find logarithm of numbers greater than 1, we use positive powers of 10. While to find the logarithm of numbers less than 1, we use negative powers of 10. That means for numbers less than 1, we use the bar notation in their logarithms. Let's see our first example. What are the characteristics or integers of the logarithm of the following numbers? Now, can you remember where you can get the characteristic or the integer of a logarithm? Let's see if you can still remember. From the solution, we can see that to get the characteristic or the integer of a logarithm, we need the standard form. We get the characteristic or the integer from standard form. For question A, the number is 29.34. Writing this number in standard form is 2.934 times 10 raised to power 1. The characteristic is the power of 10, which is 1. In the same vein, question B, the number is 0.064. Writing this number in standard form, we have 6.4 times 10 raised to power minus 2. The power of 10 is the characteristic, which is bar 2. Also in question C, the number is 56,200. Writing this number in standard form, we have 5.62 times 10 raised to power 4. The power of 10 is the characteristic, which is 4. Now, following this pattern, can you tell the characteristic of the numbers in question D and E? Let's see if you are right. For question D, the characteristic is bar 5, while for question E, the characteristic is bar 3. Here the numbers are having bar notation because they are numbers less than 1. I hope question 1 is clear to you. Moving on, let's see our second question. Use logarithm tables to find the logarithm of these numbers. Once again, do you know the two parts of a logarithm? Let's see if you can still remember. From the solution, a logarithm should have two parts, which are the characteristic or the integer and the mantissa or the decimal fraction. For question A, let's find the logarithm of 374.5. To get the characteristic, we write the number in standard form, which should be logarithm of 3.745 times 10 raised to the power 2. Don't forget, the power of 10 is the characteristic which begins the logarithm. So the characteristic is 2. So we place a point after 2. Let's know the mantissa or the decimal fraction from logarithm tables in your 4-figure table. Checking this out in your logarithm of numbers tables from your 4-figure table, we are going to check 37 under 0.4. That should give us 5729. Checking difference 5, that should give us 6. So we add the difference. Adding the difference, we are going to get 2.5735. That means the logarithm to base 10 of 374.5 is 2.5735. For question B, let's know the logarithm of 0.005812. Of course, we start by writing the number in standard form to get the characteristic or the integer. So from standard form, which is 5.812 times 10 raised to the power minus 3, the characteristic is the power of 10, which is bar 3 in logarithm form. So minus 3 in standard form as the power of 10 becomes bar 3 in logarithm form. That starts the logarithm. To know the mantissa or the decimal fraction, let's use logarithm tables from our 4-figure table. Checking this out, we're going to check 58 under 0.1. That should give us 7642. Checking difference 2, we are going to have 1. Don't forget to add your difference. Finally, the logarithm to base 10 of 0.005812 is bar 3.7643. I hope question 2A and B, they are clear to you. Now that you have this idea, can you find the logarithms of the numbers in question 2C, D, and E? Let's see the answers. For question 2C, D, and E, the solutions are displayed here. For question 2C, the logarithm of 0.802 is bar 1.9042. Coming from standard form, and logarithm of numbers table. For question 2D, the logarithm of 0.000004 is bar 6.6021, coming from standard form and logarithm of numbers table. While for question 2E, the logarithm of 0.0005192 is bar 4.7154. I hope you got these questions right. Looking at question 3, let's use anti-logarithm tables to find the numbers whose logarithms are displayed here in question A and B. Let's see how it works. Using our anti-logarithm of numbers table in question A, the anti-logarithm of bar 2.4997, we are going to start checking our anti-logarithm table from the point. We are going to check the decimal fraction first. So checking our anti-logarithms table, let's check 0.49 under 9. That should give us 3155. Looking at difference 7, you are going to get 5. Please add your difference. That gives 3160. To get our final answer, we are going to use the characteristic, which is bar 2, in writing a standard form of 3160. That will give us 3.160 times 10 raised to the power minus 2. The minus 2 is coming from the characteristic, which is bar 2 in the original question. So writing that standard form in ordinary form, the number in question A is 0.03160, which is also 0.0316, because the last 0 is not significant after the decimal point. In the same way, in question 3B, checking out the anti-log tables, of course we start from the decimal fraction, which is the point. So looking at 0.82 under 2, in our anti-logarithm tables, we have 6637. Of course, checking out difference 6, that should give us 9. Adding your difference, we have a total of 6646. Once again, let's attempt writing this number in standard form, but using our characteristic, which is bar 5, as our power of 10 in the standard form. That should give us 6.646 times 10 raised to the power minus 5. The minus 5 is coming from the bar 5 in the original question. So writing this in ordinary form, the number in question B is 0.00006646. Now let's talk about calculations using logarithms. The principles of calculations using logarithms depend on the laws of indices. Don't forget, we define logarithm as an index, which is the singular for indices. We have 4 calculations here. Let's see how we do these calculations using logarithms. Number 1, multiplication of numbers. We add the logarithms. Number 2, division of numbers. We subtract the logarithms. Number 3, power of numbers. We multiply the logarithm by the power. And number 4, root of numbers. We divide the logarithm by the root. Please take note of these principles. Knowing the principles for calculations using logarithms, let's solve our last question. Question 4. Use logarithm tables to calculate these problems. In question A, we have multiplication of numbers. In question B, we have division of numbers. In question C, we have power of number. While in question D, we have the root of the number. Let's see the solutions. In question A, we are multiplying numbers. Here we'll look for the logarithm of the numbers 0.0672 and 0.09853. When you get the logarithms, to multiply numbers, we add the logarithms. So adding the logarithms, we have about 3.8209. Lastly, we find the anti-logarithm of that result. That should give us 0.006621. The answer to question A is 0.006621. In question B, we are dividing numbers. So here, we are dividing 0.7662 by 9.325. We look for the logarithm of the numbers. Then to perform our division using logarithms, we subtract the logarithms. So subtracting the logarithms, we are going to get about 2.9147. Find the antilog of that result. Should give us 0.08217. The answer to question B is 0.08217. In question C, we have the power of a number. Question is 0.2945 raised to power 4. Here we find the logarithm of the number. Then we'll multiply the logarithm by the power, which is 4. Multiplying by 1.4690 by 4, which is the power in question, we are going to get by 3.8760. Finding the anti-logarithm of that result, we are going to get our answer as 0.007516. The answer to question C, which is 0.2945 raised to power 4, is 0.007516. Lastly, in question D, we have the root of a number. The cube root of 0.06642. Here we are going to look for the logarithm of the number, which is about 2.8223, and divide by the root, which is 3. But 3 cannot divide by 2. So we're going to do a little manipulation here. 3 can only divide the bar notation of its multiples. 3 can only divide by 3, by 6, by 9, by 12, by 15, and its multiples in bar notation. So let's pick any of the multiples of 3 in bar notation and work with it. So the original characteristic, which is bar 2, let's change it to bar 3. Before that, we are going to separate the characteristic from the decimal fraction. So the characteristic in the logarithm is bar 2, separated from the decimal fraction, which is 0.8223. Changing bar 2 to bar 3, but of course we are going to add 1 to it to make it equivalent to the original bar 2. We are going to have bar 3 plus 1.8223 divided by 3. Performing your division, 3 dividing by 3 is by 1 because 3 can divide by 3. That's why we made this manipulation here. 3 dividing 1.8223 will give you 0.6074333 and recurring. So adding up the characteristic bar 1 and the decimal fraction, we are going to have bar 1.6074 to 4 decimal places. We are approximating to 4 decimal places because we can only check 4 figures in our 4-figure table. So checking out the anti-logarithm of the result, which is bar 1.6074, our final answer is 0.4050 or 0.405 because the last 0 is not significant after the decimal point. I hope question 4 is clear to you for calculations using logarithms. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic, number and numeration, talking about logarithm of numbers less than 1, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much for learning today.